Hello friends, today in this session I am starting a new chapter, Logarithm. Logarithm is a very important chapter and various questions are based on logarithm in the different chapters of the mathematics. We will start with the basic of the logarithm, properties of the logarithm and their utility. Now we start with the basic of the logarithm. Suppose x की power y is equal to z. In the logarithm, we will write it as base log base x z is equal to y. For example, we know that 2 की power 4 is equal to 16. Therefore, in the logarithm, we can write it as log base 2 16 is equal to 4. Similarly, suppose if 3 की power 3 is equal to 27, in the logarithm, we will write it as log base 3 27 is equal to 3. Now, you have learned how the exponent can be written as a logarithm. Now we will learn how the logarithm can be written as an exponent. Suppose log base xz is equal to y. In, in the exponent, it can be written as x की power y is equal to z. For example, we know that log base 10 100 is equal to 2. In the exponent, we will write it as 10 की power 2 is equal to 100. Similarly, we know that log base 2 की power 4 is equal to 2. Therefore, in exponent, we will write it as 2 की power 2 is equal to 4. Now, you have learned how you can convert exponent into logarithm and logarithm into exponent. Now we come to the properties of the logarithm. Suppose log base x m into n is equal to log base x m plus log base n. Second property is log base x m upon n is equal to log base x m plus log base x minus log base x n. Third property is log base x m की power n is equal to n log base m log n base x into m. Fourth and very important property is log x की power y m is equal to 1 upon y log base x m. To y log base xy exists only when number 1 y should be greater than 0. Number 2, it means this y should always be a positive number. Number 2, x should be greater than 0, but x cannot be 1. Again, log xy exists only when y is greater than 0, x is greater than 0, but x cannot be 1. By this property, various questions are asked. For example, suppose log base x minus y, x minus 4 of x minus 2. Question comes, what is the value of x when x log base x minus 4 of x minus 2 exists? Then value of x. Again, since x minus 2 is written here, first x minus 2 should be greater than 0. Implies that x should be greater than 2. Again, x minus 4 is in the base. Therefore, x minus 4 should be greater than 0. Implies that x is greater than 4. X minus 4 should not be 1. 1 implies that x should not be 5, should not be equal to 5. That is, x cannot be 5. Now we come that on a number line, suppose it is a number line, it is 2, it is 4, it is 5. X is greater than 2, it means x should not be 2, x should be greater than 2. Right hand side of 2, x should be on the right side of 2. Similarly, x is greater than 4, therefore x should be greater than 4. X should not be 4. And x is not equal to 5. X is not equal to 5, therefore x cannot be 5. If we take the common solution of x, then solution is x should be greater than 4, but it should not be 5. Therefore, we can write that x belongs to, neither 4 is included, and 5 can be taken. X belongs to 4 comma 5 union again 5 comma infinite. It is the solution. It means log base x minus 4, x minus 2 exists only when x belongs to 4 comma 5 union 5 comma infinite. Now I am taking another example. Suppose log x minus 3 exist, then what should be a value of x? Then value of x. Again, x minus 3 is here. The first condition is x minus 3 should be greater than 0, implies that x is greater than 3. Second condition is that x is greater than 0, implies that x is greater than 0. X is not equal to 1. These are the conditions. Now we take a number line. X equal to 0 is here, 1 is here, and 3 is here. Again, x is greater than 3. It means x should be here, but 3 cannot be here. X is not 0. It is not 0. X is greater than 0. X should be here. Now the common values of this is coming that x is greater than 3. Therefore, log base x, x minus 3 exists only when x is greater than 3. Now I am taking another example. Suppose log x minus 1, 4 minus x exists, then value of x. Again, condition is that 4 minus x should be greater than 0. That is 4 minus x should be greater than 0 implies that x is less than 4. X should be less than 4. Again, x minus 1 is greater than 0 implies that x is greater than 1. X minus 1 should not be 1 implies that x is not equal to 2. These are the conditions when x minus 1, 4 minus x exist. Now on a number line, it is 1, it is 2, it is 4. First condition that x is less than 4. The x is less than 4, it means x should be below 4 and x should not be 4. Second condition that x is greater than 1. X should not be 1, but x should be greater than 1. And x is not equal to 2. X is not equal to 2. Now, the common value of x is coming that x should be between 1 and 4 only, then x minus log x minus 1, 4 minus x exists. Therefore, but 2 should not, x should not be equal to 2. Therefore, log x minus 1, 4 minus x exists only when x belongs to first 1 comma 2. Neither x should be 1, not x should be 2. Therefore, x belongs to open interval 1 comma 2. Union x belongs to 2 comma 4. That is 2 comma 4. Now, you might have learned that we can find the different value of x for which some function of x exists. It is all for today. In the next session, you will learn the other properties of the logarithm. Thank you.